Here's another problem out of chapter 9, and it's section 4, and oh, they want to do the volume of a cube. Okay, a volume of a cube. Now, you think about that for a little bit, and cube, Rubik's Cube, I mean, you've all seen one, and perhaps some of you are able to manipulate them. So a cube is a three-dimensional figure. Yep, length, width, and height. Okay, and so the volume is going to be a number that we can use to determine the capacity or the holding content inside of if our Rubik's Cube were hollow, for example. Now, I got a couple of visual aids that I'm going to use, and we're gonna work this problem. Look, okay, so it's a solid metal, and what's the volume? I guess how much metal did it take to, cubic yards of metal did it take to make this thing that it's 8 yards on the side? All right, so use your imagination a little bit. All right, so what is this? Well, this is a little pile of individual blocks, and you can't tell it, but I'm going to flip it in a minute where you can. But this is three blocks this way. 1, 2, 3. You see that? 1, 2, 3 blocks this way. 1, 2, 3 blocks this way, right? And by the way, this is 3 blocks high. So this is a cube. It's not a cube that is 18 on the side. It's a cube that's 3 on the side. And so how many physical blocks are in this stack? Well, you tell me. It looks to me like if it's 3 high and there's 3 times 3 on the side, then there must be 9. 1, 2, 3, 4, 5, 6, 7, 9 on each level, and there are 3 levels, so that must be 27. Oh, so in this case, in my little block here, I have a cube that is 3 on the side, and so its volume is 3 cubed. So the formula for the volume of a cube is just to take the sides and cube them, right? And the sides would include the height. So another way to say that is it's the length times the width times the height. In case we didn't have a cube, we had a shape that was not each side was the same length. Okay. So length times width times height. Now I'm going to try to flip this thing over so you can get the other view and prove to you that it is a. That ain't too bad, is it? I mean, we lost something in the rotation, but I mean, I think you can see now, what I told you. This was the bottom and this was the top, and so it was 3 by 3, right? Now, I'm dumping that off on the side. Yay. One other visual aid is a Puffs Kleenex box. Oh, okay. So how much does that thing hold? I really don't know. Have you ever measured one? Well, let's measure this one. Okay, so it's 5, but you can't see that, can you? Let me slide my box over here. I'm on this side. So there's 5 that way. 5, remember 5. 4 that way. How high is this box? About 4.5. You have to trust me on that, 4.5. So this thing is 5 by 4 by 4.5. How much is that? 5 times 4 is 20. Times 4 is 80, times a half is 10, 90. So this is 90 cubic inches. This box has 90 cubic inches of space. You say, well, why do you care about that? Well, if you assumed that each one of these little blocks was 1 cubic inch, each one of these was 1 cubic inch, I could get 90 of them. I could stuff 90 of them. I could stuff 90 of them in this Kleenex box. I wouldn't want to do that, but I could. Now, no more show and tell. I'm just going to do the problem. Now, you ready? So we have a cube that has 18 yards on the side, and the volume is going to be the length times the width times the height. And in this case, each one of those is 18. So I'll just say it's 18 to the 3rd power. And how do you do that? 18 times 18 times 18. Or if you have a calculator that has an X on it key, you say 18 to the 3rd, and you get 5,832 cubic yards. Now, why is it cubic yards? Because remember, yards here times yards here times yards here. I can multiply these numbers and convert them to 5,832. But yards times yards times yards is written as yards to the third power or cubic yards. So we should look at 5,832 cubic yards. Good job.